So let us look at a few problems in trigonometry where we might be eliminating the theta, or there may be a certain proofs involved. So this problem, first one, let us look at it. If x is equal to a sin theta, y equals b tan theta, prove that a squared by x squared minus b squared by y squared equals 1. So in the prove that, there is no ratio seen. All the ratios disappear over there. So how can we make that happen? If we see, we have a sine and a tan. There is exactly no identity directly which relates these two. We have tan theta is equal to sine by cos as a ratio, but that cannot help here. So we will take another approach. Let's see how we do it. So we have x is equal to a sin theta. Now let's bring the sin theta this side. So I can write it as 1 by sin theta equals a by x. Similarly here y equals b tan theta. So the y equals b tan theta, I can write it as 1 by tan theta equals b by y. So now 1 by sin theta, I can write it as cosecant theta. Cosecant theta equals a by x, and 1 by tan can be written as cot theta. Cot theta equals b by y. Now when I look at these two, cosecant theta and cot theta, I can form a relation. The relation is cosecant squared theta minus cot squared theta equals 1. Cosecant squared theta minus cot squared theta equals 1. So when I substitute, instead of cosec theta, I can substitute a by x. So a by x the whole square minus b by y the whole square equals 1. Or I can write it as a squared by x squared minus b squared by y squared equals 1, which is exactly what we need to prove. Okay, so let's look at another problem now. So the problem states, if x equals a sin theta plus b cos theta and y equals a cos theta minus b sin theta, prove that x squared plus y squared equals a squared plus b squared. So here I have to take the left hand side. The left hand side is x squared plus y squared. So x squared plus y squared. Let me just substitute the x and the y directly. The x is a sin theta plus b cos theta the whole squared plus a cos theta minus b sin theta whole squared. So this can be written as a squared sin squared theta. This is a square plus, so we know x plus y whole square is x squared plus y squared plus 2xy. So we just use that. So a square plus, this is the second part, so b square cos square theta plus 2ab sin theta cos theta plus 2ab sin theta cos theta. The mistake many make is they take x squared plus y squared equals x squared, that is x plus y whole squared equals x squared plus y squared. So please be careful, know the identities properly. So then this plus the second part, let me write it down over here. This becomes a squared cos squared theta plus b squared sine squared theta minus, because it is x minus y whole square. So 2 minus 2xy should be there. So that is why we have the minus over here. Minus 2ab sine theta cos theta. So we have a plus 2ab sine theta cos theta minus 2ab sine theta cos theta. They get cancelled out, and then here we have a square into sine squared theta plus cos squared theta. I am taking a squared common and writing these two within the brackets, plus b squared into, similarly I can write it as cos squared theta plus sine squared theta. So we know sine squared theta plus cos squared theta is 1, so I can write it as a square plus, similarly cos squared theta plus sine squared theta is also 1. So I have equals a squared plus b squared, which is the right hand side over here. So we have proved it. Now let us look at the third question. So the third question says, if x equals r sine alpha cos beta and y equals r sine alpha sine beta and z equals r cos alpha, prove that r squared equals x squared plus y squared plus z squared. So in this question, let us take the right hand side. So what is x squared? X squared equals r squared sine squared alpha cos squared beta. So let's write the whole thing here. X squared plus y squared plus z squared. This r squared plus sine squared alpha cos squared beta. Then y squared. What is y squared? Plus r squared sine squared alpha sine squared beta plus z squared. Z is r cos alpha. So z squared would be r squared cos squared alpha. So it is r squared cos squared alpha. Now look at these two terms, the first two terms. R squared sine squared alpha is common in both these terms. So let's take that out common. So r squared sine squared alpha into cos squared beta plus sine squared beta plus the last term that is over there, that is r squared cos squared alpha. Now we know from the identity cos squared beta plus sine squared beta equals 1. So here we have r squared sine squared alpha, the whole thing becomes 1, plus r squared cos squared alpha. So in these two terms r squared is common. Let's take it out. R squared into sine squared alpha plus cos squared alpha. Sine squared alpha plus cos squared alpha is 1. So this is equal to r squared, which is the left hand side. So we have proved that x squared plus y squared plus z squared equals r squared. I hope you understood these three problems, and if you have any doubts, you can always get back to me.